When solving a system of equations, we know that everything has to be lined up. The x's, the y's, the equal signs, and the constants. However, in this problem, the terms are not lined up, so we are going to have to rewrite one of the equations. The top equation I'm going to keep as is. The top equation has my two variable terms on one side of the equal sign and a constant on the other. So I'm just going to copy that one over. 2y plus 3x equals 9. However, it's the bottom equation that I'm going to rewrite. I want to get to the form where I have y, then x, equals, and then the constant. So I'm going to subtract 2y from each side. Since this is an x term and this is a y term, I cannot subtract them. So I need to write them horizontally. I said I want y plus x equals constant, so I'm going to write the y term first, negative 2y, plus 4x equals negative 2. Now I'm all set. Negative 2y plus 4x equals negative 2. Now I have everything lined up the way I need it. I have my y's, my x's, my equal signs, and my constants. Now I look for the coefficients to the same number, but one positive and one negative. I have that right here with the y term, so I'm all set to add. Break this into 3 pieces. The y's will be eliminated because 2 plus negative 2 is 0. Add the x's, and then add the constant. I then continue to solve for x by dividing each side by 7, and I find that x is equal to 1. However, I'm not finished. Since I have 2 variables, 2 equations, I need 2 answers. I can substitute this x equals 1 into any one of the equations. I'm going to go with the top equation, so I'll rewrite 2y plus 3x equals 9, and then I'll substitute 1 in place of x. And I'll continue to solve for y. I want to get y by itself, so I cover up the 2y, because I need to get rid of the 3. So 2y is then equal to 6, and finally divide each side by 2 to get y alone, and y is equal to 3. Therefore, my answer as an ordered pair is 1, 3. So I want the x value coming first, x, y.